Okay, welcome to our video. We will talk about Risa, reduced instruction set architecture, and we have team. And what is Risa? So before we go view there about Risa and risk, we will have to know what is the definition of instruction set. And before we know instruction set, we will have to know at least a little bit about how does computer work. So how does computer work? Imagine we have a set of computer and we're about to input the letter Y to the monitor. So the first thing that we gotta do is we have to press the Y letter, the Y button to the keyboard. And the keyboard will send signal to the keyboard controller. Keyboard controller is an interface between computer and keyboard, and it sends the signal to interact controller. It used to focusing the command that comes from input, and it will continue to the CPU. And inside the CPU, the signal will be sent firstly to the control unit to decide what is the appropriate action that the ALU will have to do. And it will send to the ALU or ALU or arithmetic logic unit, and it will continue to the register and send back to the ALU and send back to the control unit and send to the charge memory, and it will continue the ROM bias, and it will continue to the keyboard controller and send back to the ROM bias and send back and send to the RAM and get continue to the VGA, and then it will send to the monitor, and your letter will be shown. This is the simple figure of CPU. So we will talk about instruction set. So what is instruction set? Instruction set is simply a collection of commands or operations that a processor or central processing unit can execute. It is a low-level programming language that is specific to a particular CPU architecture. The instruction set architecture, or ISA, defines the set of instructions that a CPU understands and can execute. There are three classifications of instruction. The first one is arithmetic logic instruction. It involves math and logical operations such as addition, subtraction, multiplication, and logic operation like and, or etc. The second one is data transfer instruction. It involves the transfer of data between register and memory or between register. This last one is flow control instruction. It controls the flow of program execution, including conditional instructions and instructions to jump to a specific address. We will talk about RISC, reduced instruction set computer. A RISC is a type of computer architecture that employs the design philosophy focused on simplicity and efficiency in the execution of instructions. There are some different characteristics between RISC and CISC. If you talk about instruction set complexity, RISC support a smaller number of instructions that perform simpler operation, while CISC supports a wide variety of instructions for complex operation. For the instruction format, the RISC uses a fixed length instruction format, while CISC can have variable length instruction formats. For the pipeline design, RISC has a simpler pipeline design, while CISC can have longer pipelines with more complex stages. And if you talk about memory access, RISC relies on load store architecture. It is memory access through load and store instructions, while CISC support instructions that can directly operate on memory. For the performance and optimizations, RISC designed for executing instructions in a small number of clock cycles, while CISC might require more clock cycles to execute instructions. And the last one, for the code density, RISC might require more instructions to perform a task, resulting in larger program size, while CISC can often perform more operations in a single instructions, leading to smaller program size. So we have illustration between CISC and RISC. So we can see the CISC have fewer instruction, but each instruction is complex, while the RISC has more instruction, but each instruction is really simple. Because of what? Because the complex instruction that used to be in CISC is divided to prevent the overload of work in the processor. So CISC have greater complexity in processor because it has ability to execute a program without in a large number. Well, RISC has greater complexity in compiler to prevent processor doing the hard work. In simple, RISC breaks down complex tasks into simple instructions and hands them over the hardware. And RISC has also easier hardware workload. So there are three design features in a RISC. The first one is one cycle execution time. So it is refers to the concept where an instruction can be executed within a single clock cycle. In architecture, a clock cycle is a time interval required for the clock signal to complete one full cycle. Therefore, instructions can be executed within one clock cycle are considered to have one cycle execution time. Let's say we want to calculate the product. It is 5 times 10. Then we can see the difference of code between CISC and RISC. A minimalist RISC ISA doesn't have a multiplication instruction. So on the RISC system, the multiplication problem will be tackled like this. But syscode, besides being short, takes more cycle time to execute. As in any architecture, moving data between register addition and loop operations each consume one clock cycle. So let's also assume that multiplication operation take 30 clock cycles, comparing to code fragment we have. So we can see that RISC has fewer clock cycles than the CISC. It because the multiplication take 30 clock cycles. So we will talk about pipelining. So what is pipelining? Pipelining is a technique used in computer architecture and CPU design to improve instruction throughput and overall processing speed. It allows for the parallel execution of multiple instructions by breaking down the instruction execution process into several stages. Each stage represents a specific task in the instruction execution cycle. We have an analogy. Imagine there is a man called Dave, and Dave has for loads of clothes to wash, dry, and fold. And he also has washer that take 30 minutes in one process. And he has also dryer takes for minutes. And the folder takes 20 minutes. If we using the sequential laundry, it will be look like this. You know that they've working finishing all of the task by himself. So he has to uh, do all of the I mean he has to finish all of the loads of clothes uh, in different time. But for pipeline laundry, they just just need 3 hours to finish it because uh he doing different tasks in one time like this. This is pipeline executing 3 LW instruction, assuming delays as in the sequential case and pipeline processor with the clock cycle times of 2 seconds. The last one we will talk about large number of register. Why do we need many register? It has some reason. The first one is performance optimization. With a large number of registers, programs can temporarily store calculation results or intermediate values without the need to store them in the main memory. This can improve overall performance because accessing register is much faster than accessing main memory. It also for reducing memory dependencies. By using numerous registers, RISC can reduce dependence on memory operations. This enables faster instruction execution since data can be accessed directly from register without having to go through memory. The third one is storing intermediate values. Register can be used to store intermediate values during the execution of function or code block. This reduces dependence on memory and enhances instructions execution efficiency. And the fourth one is compiler optimization. The abundance of register in RISC architecture provides greater flexibility for compilers to generate optimized code. Compilers can efficiently utilize register to store intermediate values and avoid the use of slower memory instructions. The last one is execution speed improvement. Fast access to registers allow instructions to be executed more efficiently, supporting the one-cycle execution time principle that is characteristic of RISC. So we have the figure architecture of ARM or Advanced RISC Machine. So the ARM architecture is a family of reduced set instruction and is a family of RISC architecture for computer processor designed for efficient and power-sensitive computing. ARM processors are widely used in various applications, including mobile devices, embedded systems, and increasingly in other computing environments. Here are key features of ARM architecture. The first one is RISC design philosophy. Its simplicity on processors follow the RISC philosophy, emphasizing a simple and streamlined instruction set to enhance execution speed and reduce instruction set. ARM processor typically have smaller set of instructions compared to CISC architectures, allowing for more straightforward and efficient instruction. The instruction set architecture. It has ARM instructions are of fixed length, usually 32 bits, which simplifies decoding and execution. And ARM uses load store architecture, meaning that data processing operations are performed only on register and data is transferred between memory and register using separate load and store instruction. And the register ARM processor typically have a set of general-purpose registers that are used for computation. The number of registers and their specific roles may vary across different ARM architectures. The fourth is pipeline architecture. ARM processors employ a pipeline architecture allowing multiple instructions to be in different stages of execution simultaneously. This improves overall throughput. Techniques such as branch prediction and data forwarding are used to mitigate pipeline hazards and improve efficiency. And 5. Time and time to instructions. ARM introduced the time instruction to reduce code size by using 60-bit instructions alongside the regular 32-bit instructions. And Time 2 extends the original time instruction set to support both 60-bit and 32-bit instructions, providing a balance between code density and performance. Architectural version. These are notable versions of the ARM architecture. ARM v7 is widely used in mobile devices, while ARM v8 introduced the 64-bit architecture alongside the existing 32-bit architecture. Memory management. ARM processors support features like memory management units for virtual memory support and memory protection. And ARM processors often include charge to improve memory access speed and power efficiency. ARM architecture are known for their power efficiency, making them suitable for battery-powered and energy-conscious devices. For scalability, ARM architecture is scalable, allowing for implementations ranging from simple microcontrollers to powerful multi-core processor. And the last one is application. ARM processors dominate the mobile device market, powering smartphone, tablet, and other portable devices. ARM is widely used in embedded systems, including automotive systems, IoT devices, and more. And ARM processors are gaining popularity in server environments, especially with the introduction of 64-bit architectures. The ARM architecture's versatility, power efficiency, and scalability contribute to its widespread adoption across various computing domains. So that's all from us. Thank you for your attention.